So let us discuss this example. So in this example, we have x is equal to c close interval 0 1. Okay, c means c stands for continuous functions. Okay, so it's a set of all continuous functions which are defined on close interval 0 1. That means I can draw in this way. See, 0 1. Okay, so this is a continuous function, okay, on closed interval 0 1. So this is a member of that family. If there is any discontinuous function, suppose, yeah, this is a discontinuous function which has a discontinuity here, so it's not a member of x. Okay, so if you have a function like this, so it's a continuous, there is no any break, and which is defined on closed interval 0 comma 1, so it's a member of this family. Okay, so such functions we have. And norm 1 is also defined in this way. So norm 1 is defined with the help of integration. Okay, integration, you remember the meaning of integration. Okay, so Riemann integration says area under the curve. Okay, area under the curve, and we have to find open ball. Okay, so we have a continuous functions, and in that case we have to find open ball having center 0. Actually 0 is not a origin here. 0 means a zero function, constant function. Okay, since we are talking about functions, so that's why obviously it is also a function, and radius is 1, r is equal to 1. So let us discuss this example. Okay, just a minute, I will remove it. See, I will clearly mention here, we have whatever information we have, I will write it first. X is equal to c close interval 0 1, that means set of continuous functions, on close interval 0 1, which are defined on close interval 0 1, and norm 1. Okay, it is defined as integration 0 to 1 mod f of t dt. So this is the definition of norm 1. So let us find open ball. Now b 0 1, you remember the definition of open ball? Okay, so same definition I'm going to use here, definition of open ball. Okay, bxr, I will show you again. bxr, what is this definition? It is y belongs to x such that distance between x and y is less than r. Okay, so this is the actual definition of open ball. Okay, so let us follow this definition here. So instead of x, what we have? Instead of x we have a 0, and at a place of r we have 1. That means value of r is 1. So let us do that. Yeah, f belongs to x. X means c close interval 0 1. Okay, so we have a function, so that's why instead of y I wrote f such that distance between f and 0 less than r is 1. Okay, so the metric is okay, so norm 1 we have to use. So I will write here d1, the metric which is induced by norm 1. Okay, so let us see what will happen. So this is equal to f belongs to c close interval 0 1 such that, so this is norm f minus 0 1 less than 1. Okay, so d1 is a metric induced by norm 1. So f minus 0 we will have f. So that's why we write, so this is equal to f belongs to c close interval 0 1 such that norm f1 less than 1. So this is an open ball we have. Okay, so it is better to take a screenshot of it, and after that we will complete the remaining part of this problem. Please make a screenshot of it. Okay, okay, so this was our last step. So let us continue. So we are finding b01 is equal to, I will write the same thing again, f belongs to c01 such that norm f1 less than 1. Okay, so yeah, this is nothing but f belongs to c close interval 0 1. What was definition of norm 1? So norm 1 is defined with the help of integration. So it is integration 0 to 1 mod f of t dt less than 1. Okay, see, I will remove this part. Now it is not required. So you know that integration is nothing but area under the curve. Okay, but see here mod is, we have taken mod, that means if function is negative, no matter. Okay, if function is negative, then also it is acceptable since we have taken a mod, but the condition is area should be less than 1. That means, so I will clearly mention a set of, this is nothing but a set of continuous functions on closed interval 0 1. I'm mentioning continuous functions since basically it is a continuous function defined on closed interval 0 1, such that, okay, such that now I will mention the condition such that area between curve and x-axis is less than 1. Okay, when I will draw the diagram, you can easily understand what I'm trying to say. See, this is x-axis, right? This is x-axis and this one is y-axis. So we have a 0 to 1. So if you have a curve like this, it is continuous. Yes, 100% it is continuous. Getting? So it is continuous on closed interval 0 1. It satisfies the first condition. Okay, so when you take a mod, what will happen? The curve will look like this. Okay, the curve will look like this. Okay, just a minute. So curve will look like this. Getting? So whatever you have, okay, below the x-axis, you will have a reflection above the x-axis. So when you take a mod, the negative part will be converted into positive part. This thing will happen. Okay, but actually the part is actually negative. So we get an area between x-axis and this curve. So that means this area we will have. Okay, this area, and the area should be less than 1. So that's why this area should be less than 1. Only that curve we will have. Okay, I will just remove it. Okay, so it is a collection of all such functions. Okay, so we will stop here, make a screenshot of it, and after that we will stop. Thank you. Bye bye.